Hello students, welcome to ICT 9 4th quarter week 3 and 4. I am Laramay C221 and I will be your teacher for today. Our topic for today is all about diagnose and configure computer systems and network. Safety precautions. Occupational Health and Safety, or OHS, refers to the legislation, policies, procedures, and activities that aim to protect the health, safety, and welfare of all people at the workplace. Every worker has a right to healthy and safe work and to a work environment that enables them to live a socially and economically productive life. Safety practices should be learned early and always adhered when working with any electrical device, including personal computers and peripherals. Personal safety while working with PCs. The following statements are some safety precautions to take before working with any computer devices. Before doing anything, listen to your teacher's instructions to prevent accidents or any unwanted events that may occur in your workplace. Do not work on a computer when you are wet because you might get electrocuted. Do not remove internal devices of the computer when it is turned on. Avoid playing or running while inside the room. Always wear personal protective equipment or PPE like overall, shoes with rubber sole, anti-static wrist strap, and etc. Ask for assistance from your teacher when it comes to dealing with computer devices. Applying safety measures when handling tools and equipment are necessary to avoid certain damages. This lesson will introduce us to the fundamental knowledge of electricity. It will enable students to be equipped with the basic knowledge in electricity. Basic electrical terms. Electricity is defined as the flow of electron or electric current. It is an invisible form of energy that can be transformed into other forms of energy like heat, light, and mechanical. Electron is the negatively charged component of an atom. It has the ability to flow. Proton is the positively charged component of an atom. It had the ability to attract electrons. Matter is anything that occupies space and has mass. It can be a solid, liquid, or gas in state. Atom, basic component of matter. It composes of a nucleus, which is the central part, the protons and electrons. Current, same as electricity or flow of electron. The amount of current flowing in a circuit can be measured in ampere. Voltage, the amount of pulling force that makes the electron flow. Also known as potential difference or EMF, electromotive force, the amount of voltage can be measured in volt. Resistance, defined as the opposition of the flow of current. The amount of resistance can be measured in ohms. Conductors and isolators. Conductors are materials that easily allow the flow of current, or it has a low resistance to current flow. Examples: aluminum, gold, silver, copper, and iron. Insulators are materials that do not easily allow the flow of current, or it has a high resistance to current flow. Examples: rubber, plastic, and paper. Types of current. Number 1. Direct current. In direct current or DC, the flow of electric charge is only in one direction. This is the type of electricity is produced by batteries, static, and lightning. A voltage is created and may be stored until it is consumed. When the current flows directly in one direction, and the current flows at a specific constant voltage. This is oversimplified somewhat but good enough for our needs. When you use a flashlight, pocket radio, portable CD player, or virtually any other type of portable or battery-powered device, you are using direct current. Direct currents flow in one direction only and are constant in time. Their appearance is that of a straight line which does not vary. They are produced from power sources such as batteries, power supplies, and DC generators. Photovoltaic devices such as solar cells also generate DC power. Number 2. AC or alternating current. In alternating current, also AC, the movement of electric charge periodically reverses direction. This type of electricity is produced or generated by AC generators, commonly from a hydroelectric plant. It is the commercial power that we use in homes and offices. Delivered through a power transmission lines, AC current can be reduced through the use of power transformer to suit for its application. It can also be converted to DC for a specific purpose. In the Philippines, AC is rated as 220 volts AC at 60 Hz. Alternating currents change direction, flowing first one way and then the other. There are sinusoidal waves so that they change in time. They are produced from sources such as power supplies and AC generators. In North America, AC is 120 volts and 60 Hz or cycles per second. This means it changes direction 60 times per period. In Europe, it is generally 50 Hz with 220 to 240 volts. Why does standard electricity come only in the form of alternating current? There are a number of reasons, but one of the most important is that a characteristic of AC is that it is relatively easy to change voltage from one level to another using a transformer. While transformers do not work for DC, this capability allows the companies that generate and distribute electricity to do it in a more efficient manner. By transmitting it at high voltage for long lengths, which reduces energy loss due to the resistance in the transmission wires. Another reason is that it may be easier to mechanically generate alternating current electricity than direct current. PCs use only direct current, which means that the alternating current provided by your utility must be converted to direct current before use. This is the primary function for your power supply. So figure 3 is simplified block diagram for a PC power supply. Electric circuit. Electric circuit is the pathways of electricity to flow. Components of circuit. You have the load, commonly represented by a bulb or any electrical component that consumes electricity. Supply, commonly represented by a cell or a battery. And lastly, the switch, an electrical device that opens or closes circuit. So figure number 4 is an example of a simple circuit. Types of circuit. Number 1. Open circuit. A type of circuit that has an open path for current to flow. It means that current cannot flow in open circuit. The switch is said to be open. The current can flow into the circuit and the bulb is off. Figure number 5 is an example of an open circuit. Number 2. Closed current. A type of circuit that has a closed path for current to flow. It means that current can flow in a closed circuit. The switch is said to be closed. The current can flow into the circuit and the bulb is on. The figure number 6 is a closed circuit. Techniques for diagnosing computer systems. Computer diagnosis. Sometimes, when the problem with the system is not totally apparent and the problem may be intermittent, using a basic common diagnostic procedure may help determine what is wrong. The procedure has a number of steps that if followed each time can be of help. Rules in diagnosing computer system. Number 1. Know the facts. Educate oneself on all aspects and operation of computer parts. Continuous learning on computer technology. Number 2. Use your common sense. Number 3. Focus on field replaceable units. Identify the different types of FRU that can be used for replacement or sub-assembly. Number 4. Proper assembly and disassembly. Number 5. Factors causing computer failures and defects. People where untrained personnel would probably damage your program in PC. Firmware. Programs or software burned in chips may be corrupted. Software. Corrupted operating system would cause the system to fail. Hardware. Defective hardware components would lead to computer malfunction. Hardware conflicts and viruses can hinder your computer's performance. ESD or electrostatic discharge. Electrostatic discharge can easily damage sensitive components in your computer. Electricity. Incoming supply from AC outlet must be regulated. Power surges can damage computer units. Problem isolation. It's a detective work which you need to determine what is out of the ordinary by making detailed observation of what is not working normally and record information as you proceed. The information you will be able to gather will help diagnose your computer. You need to observe wisely. Look for any abnormalities in the unit, any change in smell or foreign smell. Listen to all sounds and error codes. Component isolation. This section will aid in determining components in your system which are failing. First, most systems have 3 major components: the monitor, system units, and printers. Some have multiple external devices. To troubleshoot, you need to isolate major components which are failing to operate. Diagnostics procedure for ATX power supply failure. Number 1. Determine whether or not the power comes on 167. Number 2. Check the switch operation with a digital voltmeter on the continuity of resistance setting. Number 3. Check the pins if the corresponding voltage are properly regulated to the motherboard. Number 4. Replace the power supply until it's defective. Flowchart of ATX power supply repair warning. You must unplug your ATX power supply from the wall before working inside the case. Things to consider. There are many devices, parts, cords, and connections on a computer, which means that there are many possible problems that could arise. In addition, your computer uses a variety of software, which can also cause problems. However, no matter what the problem is, you can use the following tips to help you find the solution. First, always check the cables. Many computer problems are related to an issue in cables and connections. The easiest first step you can take to troubleshoot most problems is to check all related cables and connections. Isolate the problem. If possible, try to isolate problem. For example, if you can't get the cursor to move on the screen, try to determine if the issue is with the mouse. If you have an extra mouse, you can alternate device to see if the one plug-in is the issue, or use the arrow keys on the keyboard to help determine if the mouse is the source of problem. When trying to isolate the problem, only make one change at a time. Take notes about error messages. If your computer gives you error messages, be sure to write down as much information as possible. If the basic troubleshooting steps don't work, you may need the information. Remember the steps you've taken or write them down. Once you start troubleshooting, you will want to remember what you have done so you don't repeat yourself. If you can't remember it, then write it down. If you end up asking someone for help, it will be much easier if they know exactly which steps you've taken. The figure number 7 is an error message. Simple solutions to common problems. Most of the time, problems can be fixed by using simple troubleshooting techniques, such as closing and reopening the program. It's important to try the simple solutions before resorting to more extreme measures. If the problem still isn't fixed, you can then try other troubleshooting techniques such as reinstalling the software. Program runs slowly or isn't working right. If a program is running slowly or otherwise isn't working right, the first thing you should try is closing the program and reopening it. You can also shut down your computer, wait a few seconds, and boot it up again. Some minor problems will work themselves out when you do this. Check the company for any known problems or updates to the software. Program is completely unresponsive. If a program has become completely unresponsive, you can press and hold Ctrl, press Alt, plus Delete on your keyboard to open the Task Manager. You can then select the program that isn't working and click End Task. If you are using a Mac, you can press Option, plus Command, plus Escape to open a similar dialog box. Problem starting or shutting down the computer button will not start computer. If your computer does not start, begin by checking the power cord to confirm that it is plugged securely into the back of the computer case and the power outlet. If it is plugged into an outlet, make sure it is a working outlet. Often, this will require you to plug a lamp or other electrical device into the outlet to make sure it is receiving power. If the computer is plugged into a surge protector, verify that it is turned on. You may have to reset the surge protector by turning it off and then back on. You can also plug a lamp or other device into the surge protector to verify that it is on. If you are using a laptop, the battery may not be charged. Plug the AC adapter into the wall and then try to turn on the laptop. If it still doesn't start up, you may need to wait a few minutes and then try again. Non-system disk or disk error message. If you get this message when you boot your computer, it usually means there is a CD, DVD, USB flash drive, or floppy disk in your computer, which is interfering with your computer's booting process. Remove the disk from the drive and restart the computer. Sometimes, Windows will freeze during the shutdown process. If this happens, the Windows is shutting down message screen will stay active on your screen. To finish shutting down the computer, press and hold the power button for about 10 seconds or until the computer turns off. The computer begins randomly rebooting or crashing. Check for overheating. Make sure the vents in the case are not blocked. Confirm that there is good airflow around the computer. Update your antivirus software and scan for viruses. Problems with monitors and speakers. No picture on the monitor. Confirm the computer is turned on. Check the brightness control located on your monitor or your keyboard and make sure it is not set too low. Check the connections for the monitor and surge protector and make sure the surge protector is turned on. Monitor goes blank periodically. You may have the screensaver enabled. If the screensaver is enabled, just move your mouse back and forth and your original screen will appear. You can change the screensaver settings by going to your control panel or your system preference if you're using a Mac. No sound. Check the volume control on your computer. In Windows, the sound icon will usually be on the taskbar, and you can also access the sound options in the control panel on Macs, and sound options are found at the top of the screen or in system preference. Most media programs such as iTunes or Windows Media Player have a volume control which will need to be turned up. Make sure the speakers are turned on. If using external speakers, make sure external speakers are connected to the correct audio port or a USB port. If your computer has color-coded ports, the audio output will usually be green. Connect headphones to the correct audio port and determine if sound is audible from the headphones. Searching the web for a solution. If you still haven't found a solution to your problem, you may need to ask someone else for help. Try searching the web for the problem that you're having, as other people may have similar problems. Also, if you have a friend, family member who knows a lot about computers, they may be able to help you. Keep in mind that most computer problems have simple solutions, although it may take some time to find them. For very difficult problems, a more drastic solution may be required, such as reformatting your hard drive, reinstalling programs, or reinstalling your operating system. If you're not a computer expert, it's possible that you could make the situation worse, so it's best to consult a professional if you think a drastic solution is needed. Tools for testing computer systems. Tools and equipment play a vital role in troubleshooting. They help the user determine the errors found in their computer hardware and network. Tools used to test hardware problems. Number 1. Screwdrivers are used for installing and removing screws in the computer unit. Number 2. Pliers and tweezers are used for picking small parts in the computer unit. Number 3. Soldering iron is primarily used for connecting terminals in the power supply and circuit board with the use of a soldering lead. Number 4. Anti-static wrist strap, mat, and spray are used for eliminating electrostatic discharge in the work area. Lens cleaner, a device used for cleaning optical media such as DVD-ROMs and CD writers. Number 6. Thermal paste is a paste used for heat dissipation of the processor. Network troubleshooting tools. Number 1. We have the LAN tester. It is a device used for testing the network connection. Number 2. Crimping tool is a device used to crimp the RG45 connector to the UTP cable. Troubleshooting computer system network. Causes of network trouble. If a computer is unable to connect to a network or see other computers on a network, it may be necessary to troubleshoot the network. A network may not work because of any of the reasons below. Number 1. Network card not properly connected. Number 2. Bad network card drives or software settings. Number 3. Firewall preventing computers from seeing each other. Number 4. Connection-related issues. Number 5. Bad network hardware. Solution. Because of the large variety of network configurations, operating system, setup, and etc., not all of the below information may apply to your network or operating system. If your computer is connected to a company or large network, or you are not the administrator of the network, it is recommended that if you are unable to resolve your issues after following the below recommendations, that you contact the network administrator or company representative. Verify connections or leads. Verify that the network cable is properly connected to the back of the computer. In addition, in checking the connection of the network cable, ensure that the leads on the network are properly illuminated. For example, a network card with a solid green lead or light usually indicates that the card is either connected or receiving a signal. If, however, the card does not have any lights or has orange or red lights, it is possible that either the card is bad and the card is not connected properly, or that the card is not receiving a signal from the network. If you are on a small or local network and have the capability of checking a hub or switch, verify that the cables are properly connected and that the hub or switch has power. Adapter resources. Ensure that if this is a new network card being installed into the computer and the card's resources are properly set and not conflicting with any hardware in the computer. Adapter functionality. Verify that the network card is capable of detecting or seeing itself by using a ping command. Windows or MS-DOS users ping the computer from an MS-DOS prompt. Unix or Linux variant users ping the computer from the shell. To ping the card or the local host, type either ping 127.0.0.1 or ping localhost. This should show a listing of replies from the network card. If you receive an error or if the transmission failed, it is likely that either the network card is not physically installed into the computer correctly or that the card is bad. Protocol. Verify that the correct protocols are installed in the computer. Most networks today will utilize TCP or IP, but may also utilize or require IPX or SPX and NetView. When the TCP or IP protocol is installed, unless a DNS server or other computer assigns an IPX address, the user must specify an IP address as well as a subnet mask. To do this, follow the instruction below. Number 1. Click Start, Settings, Control Panel. Number 2. Double-click the network icon. Number 3. Within the Configuration tab, double-click the TCP or IP protocol icon. Note, do not click on the PPP or dial-up adapter. Click on the network card adapter. Number 4. In the TCP or IP properties, click the IP address tab. Number 5. Select the option to specify an IP address. Number 6. Enter the IP address and subnet mask address. An example of such an address could be IP address 102.55.92.1, subnet mask 255.255.255.192. Number 7. When specifying these values, the computers on the network must all have the same subnet mask and have a different IP address. For example, when using the above values on one computer, you would want to use an IP address of 102.55.92.2 on another computer and then specify the same subnet mask. Firewall. If your computer network utilizes a firewall, ensure that all ports required are open. If possible, close the firewall software program or disconnect the computer from the firewall to ensure it is not causing the problem. Additional time. In some cases, it may take a computer some additional time to detect or see the network. If after booting the computer you are unable to see the network, give the computer 2 to 3 minutes to detect the network. Windows user may also want to try pressing the F5 or refresh key when in network neighborhood or refresh the network's connection and possibly detect the network. Additional troubleshooting. If after following or verifying the above recommendations, you are still unable to connect or see the network, attempt one or more of the below recommendation. If you have installed or are using TCP or IP as your protocol, you can ping another computer's IP address to verify if the computer is able to send and receive data. To do this, Windows or MS-DOS users must be at a prompt, and Linux or Unix variant users must open or be at a shell. Once the prompt assuming the address of the computer you wish to ping is 102.55.92.2, you would type ping 102.55.92.2. If you receive a response back from this address and it is a different computer, this demonstrates that the computer is communicating over the network. If you are still unable to connect or see the network, it is possible that other issues may be present. Configure computer system and network. System configuration is the way a system is set up. It is the collection of components that make up the system. Configuration can refer to either hardware or software, or the combination of both. For instance, a typical configuration for a PC consists of 32 MB or megabytes, main memory, a floppy drive, a hard drive, a modem, a CD-ROM drive, a VGA monitor, and the Windows operating system. Many software products require that the computer has a certain minimum configuration. For example, the software might require a graphics display monitor and a video adapter, a particular microprocessor, and a minimum amount of main memory capacity. When you install a new device or program, you sometimes need to configure it. which means that you need to set various switches and jumpers for hardware and to define values of parameters for software. For example, the device or program may need to know what type of video adapter you have and what type of printer is connected to the computer. Thanks to technological advancements such as plug and play, much of this configuration is now performed automatically. Safety precautions related to networks. Installing network cables, whether copper or fiber optic, can be dangerous. Often, cables must be pulled through ceilings and walls where there are obstacles or toxic materials. You should wear clothing such as long pants, a long-sleeved shirt, sturdy shoes that covers your feet, and gloves to protect you from these toxic materials. Most important, wear safety glasses. If possible, ask building management or someone responsible for the building if there are any dangerous materials or obstacles that you need to be aware of before entering the ceiling area. Safety precautions when using a ladder. Read the labels on the ladder and follow any safety instructions written on it. Never stand on the top rung of the ladder. You could easily lose your balance and fall. Make sure that people in the area know you'll be working there. Cordon off the area with caution tape or safety cones. When you are using a ladder that leans up against a wall, follow the instructions written on the ladder and have some hold the ladder to help keep it steady. Safety rules when working with cables. The tools required to install copper and fiber optic cables may cause danger through improper use. When working with cables, strictly follow the safety rules. Make sure that the tools you are using are in good working condition. Watch what you are doing and take your time. Make sure that you do not cut yourself or place anyone in danger. Always wear safety glasses when cutting, stripping, or splicing cables or any kind. Tiny fragments can injure your eyes. Wear gloves whenever possible. Dispose of any waste properly. Use common sense when installing cables and fixing network problems. Call for assistance for the tasks that you can't do on your own. Fiber optic safety. Fiber optic cables are usually for communications, but they have certain hazards. Dangerous chemicals, tools with sharp edges, light which you cannot see that can hurt your eyes, glass shards produced by cutting fiber optic cable that can cause bodily harm. Specific types of tools and chemicals are used when working with fiber optic cables. These materials must be handled with care. Chemicals. The solvents and glues used with fiber optics are dangerous. You should handle them with extreme care. Read the instructions on the label and follow them carefully. Also, read the material safety data sheets or MSDS that accompanies the chemicals to know how to treat someone in case of emergency. Tools. When working with any tool, safety should always be your first priority. Any compromise in safety could result in serious injury or even death. The tools used for working with fiber optics have sharp cutting surfaces that are used to scribe glass. Other tools pinch cables with high pressure to fasten connectors to them. These tools can produce shards of glass that can splinter and fly into the air. Glass shards. The process of cutting and trimming the strands of fiber optic cables can produce tiny fragments of glass or plastic that can penetrate your eyes or skin and cause severe irritation. The fibers can be extremely difficult to see on your skin because they are clear and small. When you work with fiber optic cabling, the working surface should be a dark matte so that you can see the tiny glass or plastic fragments. The mat should also be resistant to chemical spills. You should keep the work area clean and neat. Never pick up fiber optic fragments in your fingers. Use tape to pick up small fragments and dispose of them properly. Use a disposable container, such as plastic bottle with a screw-on lid, to store fiber fragments. Close the lid tightly before disposing of the container. Harmful light. Protect your eyes from harmful light that may be in the fiber optic strands. The light is a color that humans cannot see. It can damage your eyes before you can feel it. When you use a magnifier to inspect fiber optic cables and connectors, the light emitted from the fiber could be directed into your eyes. When working with fiber, be sure to disconnect the light source. Use special detectors to help you tell if a fiber is energized. Okay, so that's the end of our lesson for today. So for your activities and tests, just visit our GAITF link, gaitf.sims.school/lcms. Again, gaitf.sims.school/lcms. Thank you for watching.